What's good, my coders? If you're here, you're coding with Paris. The last time we chatted, we talked about one of the three legs of logic flow, functions, and your code is starting to feel a little bit more intelligent. And we're going to attack the next two legs of logic flow, but first I'm going to take you on a little bit of a side quest and talk about a paradigm that you're going to see in a lot of different languages, and that paradigm is called expressions. Yes, express yourself. Look, a lot of time and effort goes into making and editing these videos, so I'm going to take the time to ask you to like the video, subscribe to the channel, and share any of the content with anyone that you feel like might need to learn how to code. And of course, if you have any questions or comments, leave them down in the comment section below and I'll get back to you as soon as possible. Let's dive into the content. So the last time we talked about one of the three legs of logic flow, functions. But up until now, our coders had what we call a one-track mind, meaning that when we started, it just runs quickly to the end. Even with function, our code runs from top to bottom. What we're going to do is we're going to make our code a little bit smarter by introducing the second leg, which is called branches. But of course, I can't just take you straight to Mount Doom. Before we start talking about the complexities of branches and how it can make our code a little more intelligent, I have to take you on a little detour. That detour is called expressions. What are expressions in code? Expressions are something that exists in pretty much every coding language. It's simply a value or a miniature chunk of code that must be ran to produce a value. Pretty much anywhere in code where a simple value can be accepted, usually an expression can be accepted as long as it provides a value. Let's talk a little bit about the structure of an expression real quick. With your Coding with Paris tutorial folder open, let's go over and create a new folder that we're going to label lesson 4. And within that folder, what we're going to do is create a file called expressions.js. Click that file button there. We'll call it expressions.js. Don't forget the JS extension. In the past, we've used console.log in a couple of ways. The first one is we've given it a direct value. Okay. So here's an example of that. Let's try to run that quick. So go up to terminal, click new terminal, and that should open up your terminal window. And what we're going to do is we're going to go to our lesson 4 folder by typing cd lesson 4. Okay. And if you hit ls, which is just list where you're at, you see expressions.js is one of the files listed in that folder. Okay, so go ahead and type the command node expressions.js and you should get printed blah value. Okay, so that's the first way we use console.log. The second way we use console.log in our tutorial so far is we actually did so using variable. So let's set up a variable here using the let keyword here and setting it to blah variable. And then let's tell console.log to reference that blah string. Okay. Throw parentheses there. And we'll go ahead and comment this previous command out. Come down below, hit the up arrow once, and then hit enter. And you'll see that blah variable is printed. And that's just representing, what's in here. So let's go ahead and comment that out. What we're going to talk about here is another way we can give a value to console.log to print out. And that is using a function. What do you mean? Well, let's type it out quick. Okay. Remember, we set the name to the function, we type the word function, we give an open and close curly brace, and then we put some code in between. Okay. But the only thing we're going to do here is tell the function to return a value, blah function. Maybe add some exclamation points after it. Okay. And then down below, we're going to say console.log and then the name of that function. Now, you're going to be tempted to just pass the name of that function in here, but I'm going to warn you right now, that actually doesn't return what we want to return. It actually doesn't do anything. If you want to run that function in there, you have to put the parentheses. So let's go ahead and add the parentheses, add our semicolon, go down to the bottom, hit the up arrow key, and hit enter. And you see what happens is blah function. So what's happening here with all these examples that I'm showing you? Well, what's happening here is a result of code in here actually being expressed before the code out here is actually being ran. So when we talk about our topic here, expressions, what we're saying is expressions can be either one of these, right? It could be a value, it could be a variable, right? It could be a function that returns some value, but all three of these represent an expression. And you'll see this a lot in a lot of different coding languages where you have the opportunity to give a value somewhere, or you can give a piece of code that is to be expressed first, and then the value that's returned is actually being used as a part of the code. So all programming languages have examples of expressions. You can do this type of behavior everywhere. So a shortcut to remembering expressions is just that they are literally a piece or a chunk of code to be ran, to be expressed in order to give a value to be used somewhere else in the code. So let's dive a little bit deeper on expressions, why don't we? So now that we understand what expressions are, it's probably good to start diving into a way that expressions are used to make our code a little bit smarter. And one way that happens is doing something called comparisons in Booleans. You remember Booleans? It's something we talked about in the past, and it's really just a true and false value. And what it's typically used for is checking the condition of our code, right? So in code, you'll see a pattern of folks actually checking the condition of the code by comparing things. You might see that pattern very often. And we'll go through the several different ways of common comparisons you might see, okay? First one is the comparisons using equal and equal, equal, equal. What does that mean? So basically what this first comparison is doing is it's asking the computer to check a condition. It's asking the computer to check if a value on the left equals the value on the right, okay? And we'll give some examples to kind of help you understand what's going on here. So let's set a variable. Let's set a variable. Okay, and now we're going to ask our code to check the condition of a variable using that comparison syntax that we're talking about, okay? So what we did here is we're telling the console to log, but inside of here we're running an expression. And what are we telling that expression to do? We're actually telling that expression to compare the word hell to the word hello, right? And we're saying, is what's on the left, hell, equal to string value hello? Notice the double equals, which is a little bit different from the single equals. Single equals is used to set a variable typically in pretty much all languages. So in order to actually use the equals in the way you might intuitively use it is actually to use a double equal. That's actually pretty common. So what's going to happen when we run this piece of code here? Let's save our code first of all, and then go down to our terminal and go ahead and run the function. And you'll see that this actually returns false. Why is that? It's because the two things that we're comparing aren't actually equal. They aren't actually the same. And we know that. Hell does not equal hello, right? So let's go ahead and annotate that. So this value is going to return false because those things aren't equal. Let's go ahead and comment that and look at another example, okay? All right, so let's give an example of the inverse of this, okay? So something that returns the value true, okay? So let's say we actually did hello, right, equals string variable. What do you think will happen? Yes, the value true will be returned because the value here is actually equal to the value here. And let's go ahead and run that to confirm. You see true is here. Okay, let's give an example of comparing things that aren't strings. Console.log 1 equals 1. Okay, what happens here? We run this. Well, let's go ahead and comment that out, right? And then come down here and run this code. You'll see true is given because 1 does equal 1, right? Also returns true. Okay, so I think you get the point here. When you're comparing two things that are the same, using the double equals here, you just want both things to be on, I guess, equal if you want the value to be true. And if it is the case that any of these values are not equal to each other, now you're comparing the thing on the left to the thing on the right in this condition. But if any of them are not equal, then you'll get a false value. So that's an example of checking the condition. Very simple example, but I hope it gets the point across here. Okay. All right. Now let's talk a little bit about something you might see in JavaScript. Okay. So we have our comparisons. The common way you might see it using the double equals in a lot of languages, but JavaScript has something else you might see, another pattern you might see that I want to introduce you to, just so it doesn't throw you off. JavaScript has something called the triple equals, okay? And I'll give you an example of that, and then I'll explain what's going on here. Console.log 1 equals 1. So if I were to run this, what do you think will happen? I have a string here, and I'm comparing that to 1. What do you think will happen if I run this expression where we're saying, hey, is this equal to this? If I were to run that, you will see that the value equals to true, right? So this turns out as true. Any ideas why? Well, it's because we're using the double equals. And what it tries to do is it tries to be smart, and it tries to take two items that might look like each other and compare them in the same way. So because I'm taking the left and I'm comparing it to something that's on the right with the double equals, what it's saying here is that this one looks a lot like this number 1. So what we're going to do is we're going to actually change, since we're starting from the left, we're going to change this one to a string, right? And then compare those two, and then they look like the same. So we're gonna say that they're equal. This sort of behavior, though they built it in to try to be smart, actually can get you in a lot of trouble. So what the language introduced is something called the triple equals. So now let's take that same line here. Let's copy it down, right? I'm gonna go ahead and comment this out, but then let's use the triple equals. And let's run it and see what happens. So I'm gonna go down to the terminal, go ahead and run it, and you'll see that that returns false. Okay, so let's talk a little bit about that. Why does that return false? Well, this returns false because this triple equals is now adding a different layer to the comparison, right? It's saying, hey, is this of the same number and the same type? So now it's doing what we intuitively think it's doing no matter what. It's comparing the what things might look like, and as well as their actual types, whether it's a string or a number. This is the safe way to go. I would say this returns false rightfully, and I would just strive as a pattern just to use triple equals pretty much everywhere in code when you're doing the type of equals comparison that we're doing here, just to save your butt from this kind of shifty behavior that you're seeing. So anywhere in your JavaScript code where you see that double equals, go ahead and add a triple if that's actually what they mean to do. Hopefully it is. It better be. All right. So let's comment that out and move on. Let's go ahead and talk about another comparison expression that you might see in code, which is the not equals sign. And that looks like this. And basically what's happening with your not equal sign is you're asking the program to check to see if the thing on the left is not equal to the thing on the right. It's the inverse of what we learned about before. Here's an example of that, okay? Console.log, and let's throw in the expression 1 is not equal to 2. So the way you express that is using the pound sign, the bang sign or the exclamation point in the equals, okay? So let's go ahead and run this and see what happens. Why don't we? You'll see that that is true. 1 is not equal to 2. That makes perfect sense, right? So we'll do the inverse of that just for our notes here. And I'll go ahead and start typing it. That's right, 1 not equal to 1. So we'll go ahead and run that down below, and you'll see that equals false. So this is for our notes, because if I say 1 is not equal to 1, we know that's a false statement. And we'll go ahead and trip you up a little bit here. What do you think this actually turns out to be? What's the value of that? Let's go down and run the code and see. False. Why is that false? Well, this goes back to that shifty behavior, right? Because we're using our simple representation of not equals here, or our kind of shifty version of not equals, and I'll show you why. This returns false because it thinks that this is equal to this. It's saying, hey man, what are you talking about? 1 does equal 1. Shifty 1 equals 1. And so again, this type of behavior will get you in big trouble when you're writing code, because you don't want shifty behavior like this. You don't want your code translating something into something it doesn't represent. It actually isn't what it is, a string to a number. So how you would correct that is actually correct what's above. And how you would do that is you would actually say okay, and should return. What do you think it should return? Let's come down here and run it, folks, and see what happens. True, because it should return false, or true, because 1, the string 1, is not equal to this 1, because 1 is a string, right? It's not of the same type. We shouldn't even be comparing them. So this is what we want it to be, and we want it to be that way. So if you're comparing two things and seeing if they're equal, make sure there's no shifty behavior by using the double equals here for not. And we're going to start comparing numbers. The way we do this, there are a couple of different ways. Now, this is comparing numbers the way we might have compared them or represented them in school when we were learning math. Let's talk about that here. Let's look at our first way to compare numbers, which is the less than. So this is saying, is the thing on the left less than the thing on the right? Okay. The way we do that is console.log, and we say is 1 less than number 2. And let's go down here and run this. This returns true, folks. We know why. Is the thing on the left less than the thing on the right? And so the inverse is true as well. So let's go ahead and add that to our notes as well. Two greater than 1. Is 2 greater than 1? Let's run it. We see that the answer is true. So yes, returns true. Now I'm going to throw you another curveball. Let's try typing the following. Console.log, and we'll say the number 1 is less than 2. What do you guys think is going to happen here? Let's go ahead and run this and see. Wait a minute, you see a true. Now, this is kind of shifty, okay? And this is shifty because, again, with this comparison here, JavaScript is trying to be smart and is trying to translate these to the same type and then do a comparison of them. There's not really an answer for this one, not that I know of. If you know of an answer, go ahead and put it in the comments below, because you'd be teaching me something for sure. The best thing to do is to never ever do stuff like this, right? Don't try to compare things that aren't of the same type, because you end up with some really shifty behavior. And in some languages, there's no way you can do this. In JavaScript, you can, and there might be other languages out there, so just don't do it by rule of thumb. I'm just gonna put a note here that this returns true because it's shifty, but never ever do this, okay? And you should be good. A couple other comparisons I'm gonna show you here, okay? So let's go ahead and comment this, and let's look at a couple of other of these comparisons, and I think we'll be good to go, okay? We do have some funky behavior with console.log here, and we can say cats is greater than cat. What do you think will happen here? Well, let's go ahead and run that and see what happens. This will return true, right? Why is that? Well, But even though we're not comparing numbers, right? These are the same type. So it's basically just comparing length of the string is what it's doing here. So cats is greater than cats, right? This is okay when you're comparing the same type. Okay, so we are going to do one more to kind of nail this home, okay? Let's go ahead and comment out that line. Let's do console.log here and compare cats to the word lots. What do you think will happen here? All right, let's go ahead and run it, okay? If you guess false, it's because the lengths are the same between the strings. I'm just comparing the size of these, right? So this isn't greater than this in size. It's actually returning false, okay? So this is returning false. Honestly, comparing strings and code, you might rarely do this sort of thing. Unless you're writing some type of algorithm that's, you know, doing a lot of like text manipulation and trying to check to make sure that things are okay. You might get to something like this, but then you might just want to take pieces of the string and compare them to each other instead of just comparing them. Does this equal to this? Just know that something like this can happen as long as we understand that this is a comparison and that these symbols are kind of comparing the thing on the left to the thing on the right, and that expression is ran in this console.log function. You're good. To my final few comparisons, okay? The first one is going to be greater than or equal to, okay? Greater than or equal to. All right, so console.log 1 is greater than or equal to 1, okay? So what's going to happen when we run this? What's going to get printed? Well, what's going to get printed is true because 1 is greater than or equal to 1. So let's go ahead and run it. True, okay? And that's correct, okay? The thing on the left is greater than or equal to the thing on the right. Let's try the inverse. 1 is less than or equal, right? So the thing on the left is less than or equal to 0. Now this is actually going to return false. Let's try it out real quick. Yes, returns false. False because of the fact that this is kind of the same, right? Or this is saying 1 is less than or equal to 0, which we know is not true. That's false. So JavaScript does this less than or equal to or greater than or equal to. There's no answer to this by using double or triple equals. Again, just try not to use that pattern and you will not get yourself in trouble, okay? Our final thing to understand about expressions, ands or ors. Ands and ors. Ands and ors allow you to combine multiple expressions together, and that kind of helps your code become a little bit more intelligent. But with that comes a little bit more complexity. But we'll just give you some examples of how to use ands and ors, and we'll talk about when to use them and when not. Okay, so let's set a variable example value equal 1. Okay, now let's use this first example. Go ahead and type along with me, boys and girls. Example value is greater than 0 and example value less than 10. Okay, so what we did here is created a variable called example value. We made it the number 1, and we're trying to say, hey, number 1 is greater than 0, but it is also less than 10. So this expression is going to be evaluated. What do you guys think is going to equal? Let's go ahead and run that quick. It's going to equal true because 1 is indeed greater than 0, but is less than 10. Basically, both sides of these equal true. This condition and this condition, and it was good. In fact, I could wrap this with parentheses here, and it might look like math, okay? It might look like math, but let's go ahead and wrap those in parentheses. Let's go ahead and run it again, and you'll see that equals true. Basically, you have something on the left and something on the right, and we need both of those to be true for this to work. In fact, let's try it another way when it doesn't. Example value is greater than 0, right? And example value is greater than 1. Ooh, what do you think is going to happen? Let's go ahead and comment this line of code out and run that again. We got a false. And why is that false? We do know that 1 is greater than 0, but this one is definitely not true. 1 is not greater than 1. And because both of these conditions are met, where this one and this one are true, this actually returns false. Okay, let's go ahead and put what this one's returning. Okay, so why the heck do we care? Well, because when you're using an and when you see this and being used in code somewhere else, basically both of these conditions have to be true. Now, we're going to talk about the ors, which is a little bit different from this, okay? So what if you see something like this? Example value is greater than 0, or example value is equal 1. Let's actually combine another one. This will throw you for a loop. Or example value greater than 3. By the way, ors in a lot of code are represented by this bar. You can see this bar usually on your backslash button here. If you hold shift and your backslash on your keyboard, you get this bar here. And this is the way you represent or in JavaScript. Some languages have you write out the word or. A lot of them do this here. But what is this actually meaning, right? Okay. So the first piece of this is saying, hey, I want this condition to be true, or I want this condition to be true, or I want this condition to be true. Okay, so if we look at our example value 1 here, we're saying example value 1 is greater than 0. Actually, this first one is going to evaluate to true. Example that value is equal to 1. Yeah, that's actually true. But you'll see this third one is false. Example value equals 3. Let's go ahead and run this. You see that equals to true. Now, Paris, why the heck is this equaling to true when this third one is false? Well, the way the ors work is they short circuit, because the first condition it finds is true. It evaluates it as true and says, hey, well, we'll go ahead and stop what we're doing, or we'll stop reading this expression. One of these is true. We return the value true and we're good. Okay. So when you see ors, just realize if any of these are true, it's gonna actually work. Now let's flip things a little bit here and just nail it home with this final example. Example value is greater than 0. That's true, right? Example value is greater than 3. Wait a minute. Example value is equal to 1. Things are just flipped slightly, right? Actually, let's flip it even more. Let's flip it even more, okay? We'll take this. Oops. Let's do this. Let's take this one and actually put it here. Get rid of this extra or, okay? And this is what it looks like. We have example value greater than 3. Weird. This one is false. We know for sure it's false, but the other two are correct. Okay. So let's go ahead and run that by coming down here, pressing up, pressing enter, and you'll see that this equals to true. Well, what's going on here? Well, remember, this value is actually false, right? So it actually checked the next condition, or example value is greater than 0. Hey, it is greater than 0. And then it says, hey, this one is equal to 0. We're going to close this out here with a true, and we're going to return true. Is that confusing? Listen, the easiest way to remember how to use ors is to actually just consider the fact that if anything is considered true, whether it's 2 or 3 things or just one thing, right? If anything is considered true, then the expression is evaluated to true. My rule of thumb for using ands and ors is I usually try to keep them to maybe 3 deep at the most, because what's going to start to happen here, and you'll learn this once you start moving into branches of code, okay? But when we start evaluating expressions like this is going to cause your code to start becoming complex, because you have to think about, and usually you have to code to, what will happen if these conditions are met or if these conditions are not met, right? So if this expression returns true, what happens, right? You have to think about that. If this expression returns false, if one of these returns false and 2 of them return true, and your code comes through and hits a false or true, what happens? Are you getting what I'm saying here? Complexity starts to build the deeper you have these. So my rule of thumb, don't go any more than 3 deep with these. So let's talk about what we covered here. Remember, the whole reason for this whole side quest is to talk about expressions. We talked about how expressions are an important piece to making your code become more complex. They allow you to basically run whole chunks of code in a tiny little space by expressing that code first in a statement. And by space, I mean a place that accepts a value. Remember that a value must be presented in an expression. meaning that whatever it is, whether it's a value, an actual value that you're giving, a variable, or a value you're returning from a function, all of those count as expressions. We also talked about certain types of expressions that become huge in the next few pieces of coding nuts and bolts that we're going to talk about. And that is Boolean expressions, also known as comparisons. They are important because they return a Boolean. Remember, we talked about a Boolean in the past. A Boolean is a true or false value. So as you might imagine, a Boolean expression returns a true or false value. So we talked about the different ways that things can be compared and can return true or false values. It's like greater than, less than, greater than or equal to, less than or equal to, and ands and ors. Like an all-side question, you might be wondering, why is this important? Trust me, it's going to help lead into the very next thing that we're going to learn. So stick with me. Great job. That's a wrap for our comparisons and expressions. Now I think we have what we need to talk about: branches and logic flow.